I've been having some fun setting up a satellite TV system. You can buy a small dish and a satellite TV receiver quite cheaply. And it's really fun to see how many satellites you can see from your location and watch foreign language programs, of course, and watch foreign news and just play around with this fantastic technology. From my location, I think I can see about 5 or 6 satellites. Some of them you probably need a slightly bigger dish to get a decent signal. But what I want to talk about today is a thing called skew, which is something it's very important to understand because you can get much more out of a small dish if you understand this thing called skew. And of course, I'm going to explain that. Now, this is a list of various satellites I can see. Each of these satellites broadcasts hundreds of programs. The bottom one here is quite interesting because it's actually a satellite that I can see from my location, and it houses an amateur radio geostationary satellite. So I can actually send a signal up to this satellite on one frequency. I've got a transmitter I built, and this transponder will rebroadcast my signal back to a third of the Earth on 10 gigahertz. So I can transmit up to it, but I usually receive the signal on a software-defined radio online. But it'd be quite fun to actually receive the signal directly. Not sure if I can do that with my small dish. The signal might be a bit too weak. But what we're going to learn about skew is going to really help for this sort of challenge. So your satellite dish is what's called a parabola. And the metal has a certain shape so that when the satellite signals hit the metal, it's reflected to one point, a focus point. And that's where you put the receiver. And so that's the classic parabola. The problem is, of course, you've got all this electronics at the focus, and it's blocking some of the signal actually hitting the aerial. And the way they've overcome this is really clever. Imagine making a really big parabola and just cutting off a section of this big parabola some way away from the center. Any radio waves that hit it are still going to be bounced off and focused at a point. This point is now no longer in front of the antenna. So this is called an offset dish, and this is the classic satellite dish that we tend to see now on houses. And it's a bit weird because you think it's pointing straight ahead, but actually because it's offset and it's a section of a parabola, the actual satellite it's actually pointing slightly higher up than you might think. So in the UK, you can see this is my satellite dish, 51 degrees north, and you can see roughly where the satellite's coming in. It's bouncing off the dish into the receiver. We were in Cape Verde last year, which is much closer to the equator, and because the satellites look much higher in the sky at that latitude, you have to obviously position the satellite dish in a different way. So when you set up the satellite dish, you need to think of at least two things. One, you need to work out how high you need to point it above the horizon, which is known as the altitude, and you have to also point it east or west of south, which is known as the azimuth. But you also have to consider something called skew, which we'll come on to. Now, the signals that come down from the satellites are broadcast on a horizontally polarized signal and also a vertically polarized signal. So actually on the same frequency coming down from the satellite, you can have completely different programs. And in the receiver, there's two receivers actually. There's a horizontal and a vertical receiver, and you can flip between the two. So it's very important that when you set up your satellite receiver, that the receiver is set up properly horizontal and properly vertical. Otherwise, what happens is that the signals get mixed up. So this is our classic satellite dish with this receiver. The receiver is called an LNB, which stands for a low noise block down converter. It's actually a converter. It takes the 10 gigahertz signal that's hitting the dish and converts it to a much lower frequency, which is much easier to pipe down the coaxial cable to the receiver. And in this LNB, which is a marvel of technology, it's an exquisitely sensitive thing, it's an amazing thing. There's two receivers, there's a vertical one and a horizontal one, and you can switch between the two in the receiver. So if you don't get this right, you get this paradoxical situation where you can get a very strong signal from the satellite, but you get terrible quality pictures. And the reason is that instead of receiving the vertical when you want to, or the horizontal part, you're getting a bit of both and they're interfering with each other. Well, that's one reason anyway. So it's extremely important that you get the LNB, that the satellite receiver set up properly. Otherwise, you're not going to get reliable TV signals. And this angle, getting this angle right, is called the skew. So let's take an example. Imagine that the signal is coming down from the satellite towards the satellite dish, which I've shown here. You've got the vertically polarized signals in red, and you've got the horizontally polarized in blue. And they're coming down. The satellite dish is collecting these signals and focusing it on the LNB, the receiver, and everything's fine. But what actually happens usually in life, depending on where you are in the world, and depending on which way the antenna is east or west from south, even though the satellite might be transmitting a perfectly vertically polarized and a perfectly horizontally polarized signal, where you are on the Earth will depend how they look. So you can have your satellite dish set up vertically and horizontally perfectly, but it looks as though the signal's coming in skewed. So the result is that if you see here, that the red signals are no longer vertical as they were before. So when they bounce off the dish, they arrive at the LNB at the wrong angle. And in fact, the LNB here is going to pick up a little bit of the vertical and a little bit of the horizontal at the same time, which is not good. So the way to overcome this, of course, is just to turn the LNB slightly. So in this case, for example, you can see that it's not aligned properly. But if I just skew the LNB a little bit, it's now aligned perfectly with the signals coming in. So I'll just show you that again. So this is a misaligned receiver, and you just turn it a little bit, and it's now aligned with the vertical and horizontal components coming in. Fine. Now this is all okay. If you've got a satellite receiver, you just want to pick up one satellite, and the dish is mounted on the wall, that's no problem. You can do this. But if you're like me and you want to move the dish around for different altitudes and azimuths, then really you need to be able to move the LNB as well, change that angle. And this is what I've made. So I've made a little device that basically is a skew rotator. And what it consists of, I made it out of perspex, because I make a lot of things out of perspex. This is 8mm perspex, which is very strong. It's nice to deal with, and it won't rust. And so the first bit of perspex is just bolted on the side with some U-bolts, which allows me to fix this thing on my antenna rotator. And then the second bit of perspex is this triangular piece of perspex, and it's fixed with a pivot point near the bottom. The satellite dish is mounted as close to that pivot point as you can. I've cut a slot in the top here, which allows, with a pin, for this triangular shaped perspex to move. And there's a thing called a linear actuator, which is like a little linear motor. When you put a voltage on this motor, it grows or it shrinks. So basically, by putting the right voltage on the linear actuator, I can move this whole thing to the left and the right. So these things are relatively cheap, these little motors. This one is a little bit more expensive because it's a waterproof one. Obviously, I need a waterproof one because the thing's outside. And it also includes switches in it. So if you go all the way to one end, it will just stop. It won't just keep on going. And if you go all the way to the other end, it will stop. You just need to reverse the voltage. So it's rather nice. So let's just explain it again. So the middle image here shows the system with the linear motor at halfway position. And the triangular piece of perspex is straight up. So your dish is vertical. Now, if you apply a voltage to the motor, it will start to grow, and as it does that, it will start to shift the triangular perspex to the left, and therefore move the rotator around anti-clockwise. If you change the voltage, the motor will start to shrink. Then it will start to pull the triangle around to the other side, to the right, and it will shift the whole equipment, the dish and the MBA, to the right. So with this very simple little perspex system, I can adjust the skew of the antenna system by roughly plus or minus 30 degrees or so. So here's a picture of the back of it, and you can clearly see the perspex sheets. You can see the triangular sheet here. I've made them out of offcuts, which is why it looks a bit rough, but it was just a prototype, and it works really well. So at the back here, you can see the linear actuator, or the linear motor here at the back. So let's have a look at it in action. So you can see my black rotator here is not moving the dish. It's set looking up at the satellite. I'm just adjusting the skew. So it's gone clockwise, and now I'm adjusting the skew anti-clockwise. It's a very simple system. How does it get on? How does it work? I found the results have been really good, actually. On one of the satellites, I could only get 1 or 2 stations properly, and I thought I needed a bigger dish. Didn't think I was getting enough signal. But when I built this system, I found by adjusting the skew, I could get all the channels in the satellite. So it really did make a big difference. And for those satellites that are quite east or west of me, where they're quite low in the sky and the signal's quite weak, it makes a really big improvement, especially if you've got a small dish. So I've been really impressed by how well this works. And I've really enjoyed what I've learnt about this and really enjoying satellite TV. If you have any other questions or any questions at all, drop me an email. Thank you very much for watching the video.